Hello everyone, this is Mirzai from Cal Pomona, and in this lesson we're going to talk about seasonal forecasting in R. For seasonal forecasting, we typically use regression as a method of prediction. To investigate the regression model for seasonality, we're going to look into umbrella dataset from your textbook. So the first thing I'm going to do is to read the data into my platform. I already saved this data set as a CSV file and reading it to the platform using read.csv. I'm going to take a look at the head of my data, make sure everything comes to the platform correctly. As you see, we have year, quarter, period, and cells. In this case, as you see, all the variables are time variables. So we have a variable here, which is our response variable, that is changing based on time. So to get an idea of what sort of pattern we see in this data, we need to create a time series plot. To do that, we have to make sure that the data is saved as a time series data in the first place. So what I'm going to do, I'm going to create a new variable that makes the column cells a time series, and the function for it is called TS. So if I say cells is equal to the time series of cells in the data frame data, I change the cells structure into a time series. If I look at the str of variable cells and look at it, you see it's a time series from 1 through 20. So we have 20 rows of data. If you look at this data, if I highlight and show you the data, you have 20 rows, and by running this line of code, I made it a time series that goes from 1 through 20, and these are the values for that time series. Now, to be able to plot the data, we can simply use the plot function. I put cells into the plot function and execute it, and I get this plot that shows the time series of my data. Now, let's go ahead and extend the x-axis limit, because later I want to overlay my prediction over the existing forecast. So the way that you can extend the limits of x or y is by adding xlim or ylim, which lim stands for limit, in your plot function. So if I type in xlim and define a vector from 0 to, let's say, 30, now I extended the limit of x-axis as opposed to be only 20 to 30. So I'm going to go ahead and execute this again. If I look at my chart, you see that now my x-axis limit has been extended. Similarly, you can change the y-axis limit. In this case, I don't do that. Now, to add the title to my plot here, I use the option main, which adds title to my plot right here. So I'm going to go ahead and execute that line. As you see, now the title has changed to time series of cells. So this way, by using xlim, I extended the x-axis limit, and by main, I added a title to my plot. Now the next thing that we want to do is to identify what sort of pattern we see in this graph. As you see, the pattern shows a seasonality. That we have one period up here and two down, two up, two down, two up, two down, two up, two down, and so forth. So that shows a seasonality, and for seasonality we use regression. So if you look at the data, as you see, the data shows quarters that could be our seasons in this case. So quarter could be the variable that helps us to predict cells. However, quarter must be a categorical variable. You cannot use quarter as numerical because the cells is not indefinitely increasing or decreasing as the quarters increasing. So what we need to do, we have to change the quarters to categorical variables, and after that set up a regression for forecasting cells based on quarters. So that's what I'm going to do next. So first I'm going to save data quarter. So next thing I'm going to do is that in data frame data, I'm going to save quarters as categorical variables. So the function for it would be as factor of the same variable. So when I do that, if I look at the structure of my data, you see now that the quarters are factor. If you looked at this structure of this data before you're running this line, it would be numeric. So you can test it for yourself. If I go back and execute the first line again and look at the structure of data, you see quarters are integer, they're a numeric variable. However, when you execute this line and look at the structure, it changes to factor. Now it's ready to be input to your linear regression model. So I would say my output is equal to linear model, in which you're forecasting your sales based on your quarter. And the data frame you're using is called data. So if I run this line, look at my output, you see the model. Now, if you want to see what variables are significant or not, you need to run the summary function. So if I execute the summary function over my output, you see that the third quarter is not significant. However, intercept, second quarter, and fourth quarter are significant. Please note that in R, the dummy variable of the quarter first has been removed as opposed to quarter 4. So typically in the class, when we do it with Excel, we have to remove one of the quarters and we would drop the last quarter or last categorical variable. However, in R, by default, always the first one has been removed. The point is your model still is going to be as accurate, and your R-square is not going to significantly change when you do that. So as you look at the adjusted R-square, it's about 76%, and which is not a very strong model, but still is very good. And your model is significant because the p-value of the f-test is less than 5%. And all these variables are significant except quarter 3. So I have to rerun this model by removing my quarter 3 from the pool of variables. So the way that we do that is using exclude. So you have to put this factor here, which is quarter, and you want to say exclude in the factors. Which one you want to exclude? You want to exclude quarter 3. So that's the one that you put in here. So you say factor quarter exclude category 3 or quarter 3 in data frame data. If I execute this line and look at the summary output, you see that quarter 3 now has been removed and only quarter 2 and 4th are remain. If I want to look at my model, it's going to be 124 plus 28 multiplied by Q2 minus 29 multiplied by Q4. The model is significant. Adjusted R-square has increased to 81%, which is a great model now. By removing an insignificant variable, you were able to increase the accuracy of your model. Now that we have found the model, the next thing I want to do is to use this model to make a forecast for the next 2 years or 3 years, and then try to overlay the prediction over the existing plot that I have created here. So in R, there is a function called predict that uses the output of your regression, so basically the regression model that you have created here, to make a prediction for a new data set. But what is our new data set? So I'm going to create a new data set for the purpose of prediction. So we know that the input to this model is quarter 1, 2, 3, or 4. That should be categories. So my new data set here, it would be factor over, let's say, 3 years. So in 3 years, you're going to have 3 repetition of quarters 1 through 4. So I would say quarter 1, 2, 3, and 4, and I want to repeat it 3 times for the next 3 years. And I want to make this factor because the input to this model should be categorical variable. So if I run this line and look at new, you see new is having 4 level, 3 years, each having 4 quarter. Now I have to put this new data set into the predict function to make the prediction. So I call this pred. This stands for prediction. So pred is going to be prediction using the model that is the output of our regression here over the new data that we just created here. So if I execute that and look at my pred, you see that the prediction shows 3 is missing because we dropped quarter 3 from here. Now let's see what is the result for quarter 3. Quarter 3 is not here. So if you're in quarter 3, what happens? What is the prediction when you're in quarter 3? When you're in quarter 3, you don't have any value for quarter 2 and 4 because the flag for those are actually 0. To make this a little bit more understandable, let's write the equation here. So the cells is going to be 124 plus 28 multiplied by Q2 minus 29 multiplied by Q4. So if you're making a prediction for quarter 2, this becomes 1 and this is 0. So you have 124 plus 28, that becomes 152. For example, second quarter, you get 152. If you put Q4 equal to 1, then basically you're in quarter 4 and Q2 is 0, so you have 124 minus 29, that you get 95. What about if you're in quarter 1? If you're in quarter 1, these two are 0 and you get 124. How about quarter 3 is the same thing. These are 0 and you get 124. So whatever you have in quarter 3 is actually going to be 124. So for that, what I need to do to adjust my prediction that I have created here and make sure that in this prediction, all the ones that are NA turn into 124. So the function that helps you to identify NAs in vector prediction is NA function. So if I type in is NA pred and run it, it gives me a true false that which ones are the one that are NA. So as you see, the third element here is NA and you got true here. So I save this in IDX variable, and after that I want to make sure that in the vector prediction, whatever the IDX is true, put 124. So if I execute that line and look at the pred, you see that whatever NA I had here now is replaced with 124. So what I did, first I understood which ones are NA, then replace whatever is NA by 124 using these two lines. Another thing, if you look at here, you see that this vector, it only goes from 1 through 20, even though we have created 12. So the thing is, this model, it always make a prediction for the range of 20 data. So regardless of what we put in there, it's always going to make a prediction for 20, because the time series at the beginning that we have created is for 20 observation. So regardless of what we put in here, it always makes prediction for 20. Now, if I remove this new and just execute this part of the function, you see that it calculates all of the predictions without any NAs, because these are over the data that has been already given. So these are the prediction over the same data set that we already gave to the model. However, when we have new data that is given to it, what it happens is it failed to make a prediction for the third period, and sometimes you have to do it manually. The point here is that we know that because there is no trend, the prediction is being repeated for a certain period as time goes by. For example, if you run this part again and look at the prediction, you see that for the first period we get 124, then 152, 125, down to 94, and this gets repeated over and over again. And the reason for it is that we don't have any trend in our data set, and the data keeps repeating the same value from one year to the next. So therefore, what I can do, I can attach this data set twice back to back to see what happens down in the future. So to be able to create that overlay chart, what I can do, I can combine vector prediction with itself twice and then try to overlay that vector over the pre-existing vector. So I would say this is called new data, and I save it. So basically what I did, I attached this data to itself so that it gives me more visibility into the future. Now to overlay the chart on the plot that I already have, you have to keep this chart open and use the function lines and put the new data now into this. Now if you want to make it a different color, you can put color, for example, red, and execute this line. Now you see that not only you see the overlay, you see what's going to happen down in the future. So you see the time series of cells and its prediction. If you want to change the title of your plot, you can execute this plot again and come back to the line again. Time series of cells and its prediction. You can put, like, for example, red, and time series of cells would be black. So people, when they look at this chart, they know that what color is each of these. So I'm going to execute plot again. It goes back, but as you see, time series of cells, this is black and its prediction red. And I'm going to execute lines again, and that would overlay the prediction over the existing chart. So again, what we did overall, we set up a typical categorical regression. We extended the X limit here, and also we added a title for our chart. And after running the regression, we had to remove a categorical variable, which we did that. Then we generated new data and used the function prediction over the new data. However, when we did that, the third category prediction was NAs because we removed the third category from our prediction model. And as a result, we have to identify those and replace it with the value of 124 because when we know that for quarter 3, the prediction is 124. Alternatively, we could have just used the prediction over the output and make the prediction for the 20 row of data that we already have. However, none of these would give us prediction down to the future. So what I did, I attached prediction to itself to make a longer projection into the future, and I overlaid that graph over the pre-existing graph that we had. With that, our lesson is concluded. Please refer to your Blackboard for the assignments. Thank you.